So in this section, we'll have a brief introduction to the concept of a random variable. And to do that, we're really just going to dive straight into an example. So let's assume that we have a sample space that consists of 4 students, and we'll call them Alice, Bob, Carly, and Devin. And each of these students is an equal likelihood of selection. We can call these outcomes of our sample space. So each student has a 1 out of 4 likelihood of being selected within this event. But maybe we want a little bit more information. We have a object now, this Alice, this Bob, this Carly, this Devin, and those objects all have attributes. So let's extend this example a little bit, and let's say that each of these students are all taking 2 courses that we care about, a course M and a course N, and we'll just refer to them as that. But let's say that within each of these students, we know what percentage grade or how many points they have in each course. And we can represent those number of points by X and Y. So each student now has some information within them, some function, if you will, that we can use to extract that information as well. So to kind of delve into that a little bit more, let's say that we have a system where we know that we have some X input, and that X goes into this invisible block, and we can call this block some function that extracts data. And then the output of this X is some Y, right? That's a generalized function. We know that we have some input that goes through a system, and then the output of that system is a new value. Well, in this case, we can put in a student, whether that be Alice, Bob, Carly, or Devin, put them into some function, and then get an output that is the percentage or the number of points that they have in a given course. So there may be 2 different functions, one for course M and one for course N. But using this information, let's say that we just wanted to plot these on a number line. So if we have an X and a Y that are the number of points that each student has within the course, we can say that if we select Alice, for instance, and let's say that Alice has a score of 98% in course M. So if we were to plot that on the number line X, that might be a value right around here, some 98%. And if we were to look at the course N, that second course, then we might say that Alice only has 80% in that course. She's not doing quite as well. So we can, again, draw out that point on our number line and just say, hey, these are the values associated once Alice is selected. So we've gone from saying, hey, I've selected Alice, to now, given that Alice was selected, here's the data that I can extract about it. Now, the other piece of this that we might look at is, let's say we selected a different student, Bob. Well, let's say that Bob is doing really good in his second course. He has a 100% in that course. But because he's doing so well in that course, he hasn't really been paying attention to his other course. And that brings us down to some point here where he only has a 70% in the second course. So some opportunity for improvement there. But based on this, I've now gone and extended that I have some number line X and some number line Y. And based on which student is selected, I can then guess, for lack of a better term, or extract information about those students. And those values, specifically X and Y, that represent the percentage of points or the number of points that they have in each of those respective courses. Now, let's take this a step further and say that I'm actually more interested in computing their average between those 2 courses. Well, we all know the function for average. It's just add the 2 numbers that we got for X and Y and divide by the number of samples, in this case 2. So let's say I have some number line Z, and this Z is ultimately going to be the average of X and Y. So this would be X plus Y divided by 2, because there are 2 samples in this case. So if I take this information, then I can take the information, let's say, again, Alice is selected. I can take the information Alice provided, that she has a 98 in the first course and a 80 in the second course, and take both of those and say that Alice has a composite 89% overall, or 89 points on average between these courses. And if I do the same thing for Bob, I can take this information here and say that Bob has a composite 85 points out of 100 in his courses on average. So what we've looked at now is we have some initial values here, this X and Y, but then we've utilized those values to create some new value Z. And all of these are examples of random variables. And so now that we kind of have a little bit of a background as to why, again, the point here being that I can utilize some function to establish an output based on which of the outcomes, whether that's Alice or Bob or Carly or Devin, is selected. So to summarize, random variables can really just be viewed as a function, which associates a number or a value to every possible outcome. And I say value in general because sometimes it can be a letter, sometimes it can be a state, whether that be a pass or a fail. And so those values are associated to every possible outcome based on some function of the individual outcomes of your probabilistic system. Now, mathematically speaking, random variables, again, RVs, are the function which extends each outcome of a sample space to a real number or a real value. And a random variable can be either discrete or continuous, and a single sample space can have several or really infinite variables. There's no limit to the number of variables that you can assign to a sample space. But it's most important to recognize that kind of what we saw with our Z, that average previously, that functions of random variables are also random variables. So there's some general notation that we'll use throughout the concept of random variables that will be important when it comes to looking at random variables. And it's important that you recognize this notation now because it will be important as we look at random variables. And the general notation is that anytime we're talking about the random variable itself, kind of that function, if you will, the system that is defining the random variable, we're going to use the capital letter, in this case a capital X. And anytime we're talking about the outcome of a random variable or even the input to a random variable, the thing that we are utilizing as the input, the specific outcome of our sample space that creates that random variable, that numerical value, we're going to use the lowercase x. And this will make a lot more sense as we start looking at some examples, which we will do right after we talk about our next section, the probability mass functions.